next speaker is my colleague, Paul Astle. Paul is a chartered structural engineer, and he's the decarbonization lead in Ramble Buildings. Paul has worked on a diverse range of buildings and has contributed to many industry guidance documents and presented widely on decarbonization, carbon assessment, and lower carbon materials. Over to you.
Thank you, good morning. I know what you're all thinking. How is he going to follow that? Been thinking it myself for the last few weeks. And I'm afraid I'm going to have to lower expectations. There'll be no music from me. I would say, though, that I find it really interesting that Chiara's made some music from the urban sounds. And it reminded me of the book I'm sure many of you have heard of, Rachel Carson's Silent Spring, which is about how the risk of DDT in the 60s might mean that we might not hear any birds singing in the spring anymore. So it's interesting that we have now music from urban sounds, but let's hope that doesn't mean it's the cost of the natural sounds as well. Now, I'm going to try and answer this provocation in this session, the how can we repair the damage and move towards a regenerative future. This is me. I didn't know my face would be this big. I'm really sorry. It won't be for long. But as, like I said, my job is decarbonisation lead. My role is to support our 4,000 building designers around the world to reduce the carbon in the buildings that we design, ultimately delivering our strategy and also lowering the carbon in the buildings for our clients. But if we're really honest, decarbonisation is a less bad industry. On my best day, we're still going to emit some carbon. And I've been doing this role since last year, so being less bad since then. I have been trying to be less bad for longer, but it's been my full-time job since last year. So given that I'm really just trying to slow down the damage, you could argue I'm perhaps not equipped to try and answer this provocation. But I think that what we're doing in decarbonisation is really hopefully laying the foundations for how we're going to tackle this problem more generally, and ultimately how we will move towards repairing damage and moving towards a brighter future. So I'm going to have a go. First of all, I just want to say to all of you, well done. I think we're all humans in the room, and we've done amazing things as humans. We've built these incredible cities. We have amazing places, spaces. We've just heard the sounds that you can create from them as well. I couldn't find a good photo of Copenhagen. I'm sorry. I did look, but I couldn't quite get one in there. And it's great, and it's fantastic, and they're amazing places to be in, obviously, just like London. And we are aware there's a cost. We know this is happening, but we don't necessarily directly connect all these amazing places that we live in and we work in with the magnitude of the impact that we're having. And I mean, if that is a bit shocking to you, it's surprising, isn't it? Why can't we see this damage? Why can't we connect it to what we're actually designing and building? And carbon is a really funny one because we've had to create this whole concept of embodied carbon because we can't grasp the idea of a colourless, odourless gas being emitted somewhere else as anything to do with what we're building. So we're pretending it's somehow connected to the materials, which, by the way, causes me all kinds of problems because every now and again, people still think that the carbon is in the material. And of course, for timber it is, but other times it's not. You hear people talking about releasing the carbon at the end of life, which is also a problem. So embodied carbon is not really a great term, but it's one we've had to create to allow us to connect this damage with what we're doing. Now, I think there's a few reasons for why we can't see things, and I think that what we actually have to do, really, is these three things. We need to see, we need to measure, and we need to act. I would say that we're not talking about whether or not we can repair the damage, because we've already established humans are amazing, we've made amazing places, so I think we can repair the damage. I think the first problem is that we can't see the damage, we can't connect to it. And then we have to also measure that damage somehow, assess it, and then we have to act. So I think that's the first problem that we need to tackle. Now, I think the question then is, why can't we see it? What's stopping us from being able to understand this damage that we're doing with the materials and our designs and the buildings that we're making? And I think there's a few reasons I want to explore briefly on this about the way that we think. And actually, it touches on a lot of what we've heard already this morning in the first session. So I've been recently reading this book, which I'm sure many of you have come across, Thinking Fast and Slow by Daniel Kahneman. And in that book, he describes all kinds of processes that our brains go through, the psychology almost of our decision-making when it comes to looking at things. The main part of the book really is about the fact that our brains are frankly a bit lazy. We've evolved to make decisions as quickly as we possibly can. And that means that we filter out things that are unimportant. And we learn what's unimportant. We filter it out so we can make quicker decisions. And of course, all of us here who've gone through lots of training and education, all that's been doing is helping us to focus on what's important and disregard what's unimportant. But the problem is, I think what's unimportant actually is important. And we've learned that these things, these impacts, they're not having a direct feedback loop to what we do. So we're going to have to find a way to unlearn what we've learned and to rethink how we actually consider decisions when it comes to these impacts. Now, we're not born this way. This is something that we learn. And I was really struck by this a few months ago. I was having lunch with my family and my 5-year-old daughter. Just out of the blue, took a moment, put her knife and fork down. She wasn't using them anyway. And she took a breath and she just looked up and said, "Look at all this stuff. Where does it come from?" Which is a really good question. And I just want to point out we don't have loads of stuff. We're not hoarding stuff in our house. We have a normal amount of stuff, I think. But we couldn't answer that question, really. I mean, we might know the shops, you hope. But could you name the country? Could you name where it actually really came from? Could you name, the forest, the mine, the quarry, where these things come from? And it's the same for buildings, I think. We design buildings. Do we really know where these materials come from? And if you just think for a moment where you at home have your lunch or your breakfast in the morning and the stuff that's around you, do you know where it's from? Do you have an idea? Maybe there's a few trinkets that you've got from a few places, but otherwise, we really don't know. And I would say if we don't know where stuff's from, how can we possibly understand the damage and start to measure it? So the key point from this is that we have to ask questions like a child. We have to be prepared to unlearn what we've learned, as I said, and really start asking these questions again. Where do things come from? What's the impact? If we do that, I think we can start to really connect the issues with the materials and things that we're designing. Now, in addition to this sort of filtering, there's a complementary issue, and that is our obsession with boundaries. We love boundaries. We draw them around everything. We have site boundaries, red lines, blue lines, hoarding, everything. We love drawing a boundary. I'm always talking about system boundaries for life cycle assessments. And the thing is, they're great because they allow us to throw things out and disregard things that aren't in the boundary. And when it comes to a building, we draw a box around our building, we focus in on what's inside that box, and we really make sure we do a great job with what's in the boundary. But of course, when it comes to a building, there's lots of things that are outside the boundary. All the materials, they're coming from somewhere else. All the fuel's coming from somewhere else. And of course, the waste and the pollution is going outside as well. So the problem is, when we have these theoretical or even literal boundaries, we're disregarding all these things. Now, you could say the obvious answer is to make the boundary bigger, because that makes sense. But how big would it need to be? If we were to actually map out just a typical building and try and work out where do all those things come from, what are the impacts? If you really tried to do that, and not just in space, in time as well, because some of these impacts are in the future, we'd end up in a situation where we'd have to consider the entire world in our sort of boundary. And clearly that's not practical. I'm not suggesting we should start doing that. But it would be an interesting experiment, though, to do on one project. So we're going to have to find a way to expand our boundary, but in a practical way that means we can make better decisions. And fortunately, we do have a few things coming now. So I'm sure many of you might have come across embodied ecological impacts, where Sam, who's in the audience somewhere, I think contributed to that one a little bit. And this is from the UK GBC. And what they've done is they've looked at some typical materials, and they've had a go at trying to assign impact ratings for those materials, covering different indicators: biodiversity, climate, land, ocean, and the human side. And I think this is really the first step. This is the first step of things we're going to see a lot more often, these different frameworks that we need to start thinking about these other impacts. There's also one that's come from Expedition Engineering called Embodied Biodiversity Impacts of Construction Materials, again focusing on just a handful of materials, in this case really zooming in on biodiversity with these 4 indicators you can see. Now, I think, as I say, these are a great start. They're on a material level because it's still so tricky, and they focus in on the UK. But what's also really interesting here is the way that they've presented the results. In the UK GBC, we have this scorecard system, when you can see the sort of score out of 4 for each aspect, and in the Expedition Engineering, we have this radar scatter diagram. Now, they are not that easy to make a decision with. Right? If you look at that, you can't really tell what that means and how do we use that. And this is going to be a really big problem for us, because as we move into these other metrics, we're going to have to learn how to deal with different types of information, different types of metrics. The reality is, although I'm always complaining about carbon assessments and the problems with them, carbon is the easiest thing we're going to have to measure in this entire problem. If we look at all the other issues to do with biodiversity or water impact, or even going into society and community, that becomes a lot more difficult. We need to think about the actual place in question. We need to think about relative impacts, and we're going to have to find a way to capture that information in some kind of score, metric, call it what you will, and actually be able to use it. So it's a really big challenge we're going to have to grapple with. But let's assume that we've got the frameworks, we've figured out the metrics, we then have to do something with them. And this actually is from a project, I think from one of Austin's projects here, which is a weighting model to take all these different impact factors and to come up with a score at the end. And that's one way to do it, of course. We end up with a number at the end, one number. But I think the reality is there's a danger that with one number we miss something important. We could easily end up in a situation where we have one score that's really bad, everything else is green, and so we go ahead with it. But actually we might have resulted in some significant damage in one place. So I think this is a really important step forward and part of this discussion. But we actually need to find a way to reconcile all these different impacts and come up with a way to make a decision. And then we get to this really hard part. So how are we going to weigh up the actual decision? On the one hand, we'll have the benefits from our project, to society, to our clients. On the other hand, we're going to have all the potential impact. And we've got to make a decision. What's the right way forward? The good news, though, is that this doesn't necessarily have to be a zero-sum game. The tantalizing prospect of regenerative design is that you can have the benefits of your project and actually a positive impact on society. And that's the light at the end of the tunnel that we need to try and aim for. We're not there yet. I think we've got a long way to go, but it is starting to happen. But I think, to summarize, in order to really start addressing this challenge, how to repair the damage, we need to start thinking like a 5-year-old and looking over our traditional boundaries. And that's going to allow us to start understanding what the impacts are and what we've got to do. Thank you.